suggest the feature should be something like spinning. So this is again a rotational symmetry, because spinning is just, and by the way, what is difference between that orbiting in a if some particle is there and it is orbiting in some orbit and it is spinning about its own axis. So the basic difference is that the axis of rotation is outside the body, then you can assume the particle is just rotating something like this. And you can use the orbital angular momentum here for the quantum mechanics purpose. But if you have an analogy, and I am talking about analogy, nothing to do with the spinning, that electron is going to spin something like this on about its own axis, nothing to do like this. This is just one type of analogy. So when this type of situation is there, analogically, that some body is spinning about its own axis and about some diameter or something else, but the axis of rotation will be within the body, then obviously it is very famously known as spinning. So this kind of thing is there. But please mind it, there is nothing called spinning and nothing called rotation. This kind of situation is not there. Okay. So quantum mechanically, the thing is entirely different. And why this thing is entirely different? That can be given by Stern-Gerlach experiment. So first, in a very brief manner, we will discuss a Stern-Gerlach experiment, and we will try to learn that what was our expectation if we are thinking that the scientific world is, or our nature is just behaving like classically, then what should be the result of experiment and what will actually happen? And if it is happening, then how we can justify this thing? And this is one of the very fundamental experiment which leads to evolution of quantum mechanics. So Stern-Gerlach, two different person, and in year 1922 actually. So we have 100 year of this experiment which changed the life of all physicists, or changed the way to think about the nature. I have also posted one very nice video in an animation form, so you can see that video also. Okay. So let's go for what is going to, for this particular electron, and if we assume that electron is spinning about its own axis, what is going to happen? So Stern-Gerlach experiment is that there is some, you can have some oven is there. Why this oven? Because you have to give heat to your atom such that it has some kinetic energy. Okay. And there is some inhomogeneous magnetic field. Not homogeneous, inhomogeneous magnetic field is there. And we can assume this magnetic field is in z-cap direction. So we assume this is in z-cap direction. And let's say this is moving and in this oven we have silver atom. Why silver atom? Because silver atom is very heavy atom and its outermost orbit is 5s and there is only one electron. So whatever be the profile of that atom can be justified by the electrons, but by this particular single electron. And there are n number of different atom also which has only one electron in the outermost orbit, and they have also s shell. But silver atom has very high energy for the ionization. So you cannot ionize it in a very natural way or with some less amount of heat. So you have atom, but the profile of that atom is basically governed by the single electron which is in s orbital. If I am talking about s shell, and if I am not wrong, that will be 5s1 is the outermost orbital. there is some inner shell also. So there is one electron. If I am talking about s orbital, that means the quantum number L is equal to 0. So if we are talking about L is equal to 0, then how many possible state can be there? 2L plus 1. So there is only one possible state can be there. If something is happened due to orbital angular momentum, then obviously we have only one state. So you have 2 into 0 plus 1 is equal to one state is there. And there is some screen, and I am just making the schematic diagram. And we all know that electron is orbiting in some orbit, or electron has, and due to this orbitation there is some magnetic field, and if you have some external magnetic field, there is interaction with that particular magnetic field, and hence it is inhomogeneous magnetic field. Every dipole moment have some force onto that due to this inhomogeneous magnetic field. Classically, so we have millions number of atom there, and classically what we can assume that your atom can have all possible orientation, your magnetic moment can have all possible orientation. So all possible orientation we can assume. So what will happen? Suppose this has this particular direction. Suppose first atom has this particular direction of magnetic moment. Some can have this particular direction of magnetic moment. Some can have this particular direction of magnetic moment. Some can have this particular direction of magnetic. So you have random direction of magnetic moment you can assume. And if you have random number of magnetic moment is there, and if you are applying the force on this, so all magnetic moment will suffer some deflection. But this will suffer some different deflection. This will suffer from some different deflection, and this will suffer from some different deflection. So what we expect? We expect something band-like structure. Means this can go up to this point. 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 So you have million number of randomly oriented dipole moment, and you are acting force on this with the magnetic field, then we can have basically band type of structure. And this band type of a structure have to be only in, so we have only this particular band type of structure. So this is our classical expectation. And what we have found? We have found that we have very sharp structure which is equally symmetric, something like this. This is our expectation. This is our expectation from classical mechanics. I deliberately doesn't make it from the center because you have magnetic field, so everything is going to deflect in one side actually. So why this type of, and you can have this is also sharp, you can make something this kind of distribution. Okay, so this is very broad distribution you need. So this is just a band type of a structure. So this is our expectation. But what we expect? We expect something very sharp to exactly symmetric about this particular axis. Suppose this is your y-axis. So the particle is, atom is coming from the y-axis. So we have exactly the symmetric thing we found the trace is there either here or here. So we have very sharp line is there in spite of this band. And this is exactly 2 number of line is there. So obviously this is not happening classically. So if it is happening quantum mechanically, and if it is going to happen due to orbital angular momentum, and suppose you assume that electron is orbiting in this particular orbit, and that orbit is S orbit, suppose this is happening due to that particular rotation, then you have only one state possible. You can have only one state which is possible. So if it is happening with the quantum mechanical orbital angular momentum, then we should expect either this or this. But why this two trace? Why this two trace? So obviously, this is not obeying the classical thing. This is also not obeying the quantum mechanical. This is not also obeying the quantum mechanical orbital angular momentum theory. So obviously, this is something else. So what is that? And that quality can be given by spin. And we assume analogically that as some particle can spin either in clockwise direction or in anti-clockwise direction. So this is due to that particular analogy. And we have another form of mathematics, and that is nothing but spin quantum number will come into picture. So there is orbital quantum number, and now we are talking about the spin quantum number. And why we are talking about the spin half? This is very important. And because we are talking about the electron and we have only two trace, and spinning is also one type of rotation. So that will follow the rotational feature of quantum mechanics, rotational algebra of quantum mechanics. So suppose we assume a new quantum number, and that new quantum number, in spite of S, we assume the new quantum number that is small s, then from the symmetry of orbital angular momentum, we can have 2s for the given value of s, we can have 2s plus one number of a state can be possible. And this 2s plus one number of a state is actually 2. This is your first state and this is your second state. You can assume this is due to magnetic moment is in the up direction, and this is due to magnetic moment in the down direction. We assume that for the electron, only two direction of magnetic moment can be possible, either for the up or for the down. And then if we are talking about this particular calculation, which can be basically analogically compared to the orbital angular momentum, then I can say the S quantum number is equal to half. And if we have S quantum number is equal to half, then from the analogy, what we have SZ quantum number can be plus half and minus half. So this is the basic thing that can be derived from this particular orbital analogically. So everything is analogical here, but Dirac have just give the correct derivation for spin half particle, but currently we can just take our inspiration from orbital angular momentum, and we can assume that there can be existence of internal rotation or internal symmetry you can say that can be analyzed like a spin. So this is the whole story of Stern-Gerlach. यहाँ तक clear है?
Sir, हमने जो expectation from classical mechanics का जो graph है ना, पहला वाला, उसमें नीचे क्यों expect है, मतलब
भाई ये डिफ्लेक्ट होकर के कोई यहाँ तक भी आ सकता है, कोई यहाँ तक भी आ सकता है, कोई यहाँ तक भी आ सकता है,
हाँ
क्योंकि
सर,
रेंडमली ओरिएंटेड है ना.
हाँ, लेकिन वो बैंड ऊपर भी जा सकता है ना, मतलब
जा सकता है, बिल्कुल जा सकता है. तो यहाँ तक भी गया है, यहाँ तक भी गया है. ठीक है, आप पूरा एक बैंड की तरह कर रहे हो आप. ठीक है, आप कहीं भी हो सकता है. ठीक है, सो आपके पास दो एक्सपेक्टेशन थे. पहले आपने इसको क्लासिकली समझने की कोशिश की. अगर ये क्लासिकल होता तो आपको बैंड टाइप स्ट्रक्चर मिलना चाहिए था. सो ये आपको बैंड टाइप स्ट्रक्चर नहीं मिल रहा है. देन व्हाट यू हैव बेसिकली वेरी शार्प स्ट्रक्चर. सो ऑब्वियसली आपका फिर दिमाग जा रहा है कि ओके, इट मे बी फॉर ड्यू टू दिस ऑर्बिटल एंगुलर मोमेंटम, क्योंकि अगर कोई भी चार्ज पार्टिकल ऑर्बिट कर रही है देन ऑब्वियसली देयर इज मैग्नेटिक मोमेंट. बट वहां पर चूंकि आप एस ऑर्बिट में हो, तो देन यू हैव ओनली एल इज इक्वल टू 0. तो आपके पास एक ही स्टेट मिलने चाहिए थे. बट यहां आपको मिल कितने रहे हैं? मिल दो रहे हैं. मीन्स ऑब्वियसली इट इज नॉट ड्यू टू दिस पर्टिकुलर थिंग, this particular orbital angular momentum. So this is due to something else, जिसकी बिहेवियर एक्चुअली ऑर्बिटल एंगुलर मोमेंटम की तरह ही है. बिकॉज वी आर जस्ट टॉकिंग अबाउट एनालॉजिकली रोटेशन. अंतर यह है, वी हैव इन द फर्स्ट थिंग वी हैव टेकन द एनालॉजी that our axis of rotation is outside the body, and here we are taking the analogy that our axis of rotation is within the body. That is just an analogy, nothing to do with this particular quantum mechanical spin. So spin means doesn't take that something is going to rotate it. The spin means you can just assume there are two possible orientation of your magnetic moment. One can be up direction and another can be down direction. And that magnetic moment is associated to spin quantum number that can be written with the S. Okay. So now let's go for spin algebra. So spin algebra is exactly same thing, whatever we have learned. And now you can see this is two-dimensional vector spaces, isn't it? This is two-dimensional vector spaces. हम लोग बात करेंगे इसके बारे में क्या हो रहा है यहाँ पर. When we will go for the matrix form of this S, then we will talk it in a very detailed manner. But before that, let's go for a spin algebra. So spin algebra, so we have one ket, that ket is S and MS. You can write a small s and ms. And we have S orbital. S is your spin operator. And this spin operator has three components: Sxi, Syj plus Szk. Sx, Sy and Sz is basically 2x2 matrix. Okay, so that will be basically 2x2 matrix in a basis of S and MS. We will discuss this thing. So you have S square. So this S square can be given you S into S plus 1 h cut square. You have S and MS, and you have Sz, S, MS, and that value is equal to MS h cut, S and MS. But we have a spin quantum number. That spin quantum number is half S. Then your Sz is equal to plus half and minus half. And this will just follow all the algebra, whatever the orbital angular momentum is going to follow. That means we can have S plus operator and that S plus operator is equal to, will operate on S and MS, will have root under S plus 1 minus MS plus 1 H cut, and you have S MS plus 1, and similarly we have S minus, and that is S MS, and this value is equal to S plus 1 minus MS minus 1 H cut, and we have basically S and MS minus 1, and similarly S plus S and S will be 0, and S minus S and minus S will also 0. Same thing we have learned into the basically our orbital angular momentum, and we have also the commutator. The commutator is Sx Sy is equal to IH cut Sz, and similarly you have clockwise thing is there, so you can write something like this: Sy Sz is equal to IH cut Sx, and Sz Sx is equal to IH cut Sy. So this is all about our spin angular momentum algebra, but we have to work for spin half particle. S is equal to half. So there are two possibilities there. So two state is there. So you can have first state is half and half, and this is also popularly known as up and up. This is S and this is MS. Another is half and minus half, and this is identified as up and down. This can be also identified as half and half. This can be also identified as chi half and minus half. So all are same thing. Okay, all are same thing. So now the great challenge is that we have to write our S square operator, Sx operator, Sz operator, Sy operator in a basis of half and minus half. This is the real challenge. Clear है ये यहां तक? Okay.
Yes, sir.
Okay. Now let's try to go for first S square operator, and we are writing in a basis of half and half, half minus half, and half minus half. This is your S square operator. So we want to represent them as 2 cross 2 matrix. So we have learned all this thing. So and obviously you have S dash MS dash S MS is equal to delta SS dash delta MS dash. So same orthogonality is there, but here S is fixed because we are just talking about a spin half particle. So in general, orthogonality will lead to delta MS dash. Sorry. Okay. So S square will operate on this. What you will get?
3/4 H square.
3/4 H cut square. So these and these are exactly same. So this will survive, and all other will be what? 0, and this will be also survive. So your S square operator is 3/4 H cut square, and you have 1 0 0 1. Let's try to go for SZ operator. Okay, and so what will happen for SZ operator? So SZ, that will be h cut by 2, है ना? That will be 0, 0 and minus h cut by 2. So your SZ operator is h cut by 2, 1, 0, 0, minus 1. And you can see your SZ and S square can be simultaneously measurable, and they are simultaneously diagonalized in a basis of half, half, and half minus half. Isn't it? They are simultaneously diagonalized. We will also discuss something called CSCO in this particular thing into the next class. Abhi to dekhte hain. Now we have to just go for S plus operator. What is your S plus operator? S plus will operate on this. What you will get? Half and half per?
0.
0. S plus will operate on this. What you will get?
Half and 0.
Mhm.
H cut.
H cut, half and half. है ना?
Yes, sir.
So that
One
will
of
be
them.
H cut half and half. So you have H cut here. This will be again 0. This will be
0.
0. Why 0? Because MS and MS dash is not same. So that will be 0. So I have S plus operator is equal to H cut 0, 1, 0, 0. Very interesting. Let's try to go for S minus operator. So this is, हाँ बताइए.
सर ये ऑर्थोगोनल वो कंडीशन नहीं आएगी इसमें, सेकंड इसमें नहीं आएगी 1/2 1/2 और 1/2 माइनस 1/2 में?
किसके बारे में बात कर रहे हो? इसके बारे में बात कर रहे हो?
पर एच कट वाले के बारे में.
इसके बारे में बात कर रहे हो?
यस सर.
हाँ, जरा S प्लस को इसके ऊपर ऑपरेट करो, क्या आएगा जरा बताओ. बताओ.
ओके वो
बताओ
yes,
बताओ.
sir.
नहीं
Understood.
बताओ बताओ क्या होगा. अंडरस्टूड नहीं, बताओ क्या होगा.
सर वो MS+1 की -1
Exactly.
की स्टेट में चले जाएगा.
ये क्या हो जाएगा? हाफ एंड हाफ हो जाएगा, और जो
Half and half.
सेम है. ठीक है.
यस सर.
ओके गुड. जब भी डाउट हो तो उसे पूरा करना है, समझ रहे हो? नहीं तो एग्जाम में वहीं फंस जाओगे. आर यू गेटिंग माय पॉइंट? चलो S माइनस इसे कहां ले जाएगा?
तो 0 हो जाएगा.
0 हो जाएगा. हाफ एंड माइनस हाफ आ जाएगा. माइनस हाफ एंड हाफ इज 0.
0.
ये कहां चला जाएगा? ऑलरेडी 0 है ना. माइनस हाफ को
Yes, sir.
0 पर. ये कहां चला जाएगा?
सर ये एच कट आ जाएगा सर.
वेरी
ऊपर
गुड.
वाला
यहाँ पर
minus
क्या आ
half का चला
जाएगा?
जाएगा.
माइनस हाफ आ जाएगा. दिस माइनस हाफ एंड दिस इज विल बी h cut and this will be 0. So you have S minus operator, that is h cut 0, 0, 1, 0. Okay. Now what is my Sx operator? Sx operator is equal to S plus S minus by 2, and यही होगा ना? Yes or no? What is my
Yes, sir.
S plus? S plus operator is Sx plus I Sy. S minus operator is Sx minus I Sy. दोनों को ऐड करोगे, you will have this thing. So Sx operator is h cut by 2, 0, 1, 1, 0. This is not diagonalized. This is not diagonalized, isn't it? And similarly, we have to calculate Sy operator. And what is my Sy operator? The Sy operator is S plus minus S minus by 2i. यही होगा ना? देख लो जरा. माइनस 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 प्लस 2i को लेके जाएंगे. ठीक है. क्या होगा जरा बताओ तो ये. What is that?
सर एच कट बाय 2 0 minus I 0.
Very good. So you have h cut by 2, 0 minus I 0 I. Sorry, I and 0. यही हो रहा है ना? Just check it.
Yes, sir.
Okay. So you have S square, S Z, Sx and Sy operator. ठीक है? In a matrix form. Matrix form में spin को समझना थोड़ा ज्यादा ही आसान होगा आपके लिए, बिकॉज वहां पर तो हमारे पास फंक्शन मिल रहा था, यहां पर कोई ऐसा फंक्शन नहीं मिल रहा है ना, जिसको कि हम प्लॉट कर सके या कुछ कर सके, बिकॉज दिस इज जस्ट अ डिस्क्रीटनेस, आइदर अप और डाउन, दैट्स इट, है कि नहीं? सो now let's try to calculate the eigenvalue of S square and Sz, and then we will also try to calculate the eigenvalue of Sx also. And actually what is going to happen to this particular Stern-Gerlach experiment, I will detail in the next class. I will discuss in the next class in more detailed way. Okay, but before that we need to find what is the eigenvalue and eigenstate of S square and Sz. Okay, चलो यहां तक क्लियर है ना everyone?
Yes, sir.
Okay, good. चलिए, so we have basically 4 operator. Now thing is that I have S square operator and this is 3 by 4 h cut square 1001. What is eigenvalue of S square?
Sir, 3/4 h square and 3/4 h square.
Very good. So this is doubly degenerate, है ना?
Yes, sir.
Very good. And what is the eigenvector?
Sir, 1001.
0110. So you have eigenvector
Yes,
10 and 01. Are you getting my point? Now, if I will ask you, what will be the eigenvector related to 3 by 4 h cut square? आप क्या आंसर दोगे?
Sir, 10.
और 01 नहीं हो सकता?
01 भी हो सकता है,
हो सकता है ना? So you cannot, due to degeneracy, you cannot identify the state related to eigenvalue. कि कौन सा स्टेट है ये आप आइडेंटिफाई नहीं कर सकते हो. आर यू ओके?
Yes, sir.
10 भी हो सकता है, 01 भी हो सकता है. सो यू कैन, तो आप इसको ऐसे कुछ देख सकते हो. आपको जो दिखाई देगा 3 by 4 h cut square have either eigenstate 1001. सो आपको यहां पता ही नहीं चल रहा है कि ये है या ये है, बिकॉज दैट मीन्स this is actually 2 cross 2 subspace. You are watching just 1 cross 1 subspace. ऐसा ही तो दिख रहा है तुम्हें ना, बिकॉज तुम्हें दिखाई क्या देगा? तुम्हें दिखाई ये देगा. आर यू गेटिंग माई पॉइंट? बिकॉज फिजिकली मेजरमेंट इज व्हाट? आइगन वैल्यू. आइगन स्टेट इज जस्ट अ रिप्रेजेंटेशन. सो इसे देख करके तुम्हें क्या नजर आ रहा है? 2 cross 2 का सब स्पेस नजर आ रहा है, 1 cross 1 का सब स्पेस नजर आ रहा है. जस्ट टेल मी.
Sir, 1 cross 1 का.
1 cross 1 का सब स्पेस नजर आ रहा है ना, ड्यू टू डिजेनरेसी. बट एक्चुअली ये कैसा सब स्पेस है? दिस इज सब स्पेस फ्रॉम 2 cross 2.
2 cross 2. Yes,
So
sir.
what you need? So only S square is not enough to make a complete, to satisfy the completeness relation. अब इसी को हम एंगुलर मोमेंटम में भी अप्लाई कर सकते हैं, है ना? बट यहाँ 2 cross 2 का मैट्रिक्स है, इसलिए इसे यहाँ समझाना ज्यादा आसान है. एक मिनट मुझे बात करने दीजिए अभी, ठीक है? अननेसेसरी अभी इंपॉर्टेंट पॉइंट है, ठीक है? सो दिस इज माय 3 by 4 h cut square. Eigenvalue is there, but I am not able to figure it out which eigenstate is actually associated with this, either 01 or 10. It is very difficult for me. So what we want? We want some another operator which is going to commute with S square, which is going to commute with S square such that both can be simultaneously measurable and simultaneously diagonalize. Are you getting my point or not?
Yes, sir.
So both can be simultaneous. Now, if I am talking about SZ, so what is my SZ? My SZ is basically h cut by 2, and you have 1 0 0 minus 1. What is the eigenvalue for SZ? H cut
So
by
minus
2 and minus
minus
h cut by 2. And what is eigenvector associated to h cut by 2?
1 0
1 0. And what is eigenvector associated to this one?
0 1, sir.
0 1. So only finding the magnitude is not enough, isn't it? Now s square and sz is going to commute. You know all this fact, and this is just identity matrix, so it is going to commute with everything. So s square sz is going to commute, and we are able to find a basis in which s square and sz is actually diagonalized. S square and sx is also going to commute, isn't it? X square sy is also going to commute. But in a basis of up or half and half, s square and sx is not going to diagonalize, है ना? देखो s square और sx diagonalize है क्या? नहीं. And the thing is that now if I am going to ask you the question that 3 by 4 h cut square for s square and h cut by 2 for sz, which eigenstate is associated?
Sir, 1 0.
1 0. You can just tell with the full of confidence that is 1 0. And similarly, if I am going to ask what will be the eigenvector associated with 3 by 4 h cut square and minus h cut by 2 is what?
0 1.
0 1. So here you can easily say about your 2 cross 2 subspace. कह सकते हो ना?
Yes, sir.
Yes,
Defined.
because you have two different eigenvector, and this is due to s is equal to half and ms is equal to what? 1 by 2, and this is due to s is equal to half and ms is equal to minus half, isn't it? So this kit is also identified. ये जो है 1 0 is actually up and up, and 0 1 is actually up and down. Now you can understand with the mathematics why you need sz operator or lz operator in orbital angular momentum. Only this s square is not enough to reveal the all information about this 2 cross 2 subspace, which is popularly known as a spin. But here you can see that once we introduce sz, and the beautiful part is that this sz is non-degenerate. This sz is non-degenerate. And when we see the whole thing combined with s square and sz, then obviously we can reveal each and everything. So आपका एक counter question हो सकता है कि सर s square जब सिर्फ sz से ही काम चला लेते. How you can talk about direction without talking about magnitude? Yes or no?
Yes, sir. Magnitude भी है ना?
Basically हमें तो इसकी प्रॉब्लम सॉल्व करनी है ना.
Yes, sir.
हमें इसकी प्रॉब्लम सॉल्व करने के लिए हमने इसे इंट्रोड्यूस किया है कि नहीं? और एक्चुअली हमें जो प्रॉब्लम सॉल्व करनी है कि sx, sy, sz वो एक्चुअली साइमल्टेनियसली मेजरेबल नहीं है, तो हमने कोई नया ऑपरेटर लेकर आया है s स्क्वायर जो कि xs, xy, sz से साइमल्टेनियसली तो मेजरेबल है, लेकिन s स्क्वायर अकेले काफी नहीं है. So we need two quantum number. So we need your 2 cross 2 subspace. Are you people happy? So this is basically जिसे आप अप कह रहे थे, हाफ कह रहे थे, दिस इज बेसिकली 1-0 मैट्रिक्स, है ना, 1-0 वेक्टर भी आप कह सकते हो. सो दिस इज योर हाफ is actually equivalent to up and up is actually equivalent to chi half and half is actually equivalent to 1-0. And you can see half minus half is actually equivalent to up and down is actually equivalent to chi half and minus half is actually equivalent to 0-1. And now you can do exercise also. अब आप यहां पर एक्सरसाइज भी कर सकते हो. यहां तक क्लियर है? अब बताओ कंचन क्या पूछ रहे थे?
नहीं सर, क्लियर है.
क्या पूछ क्या रहे थे वो तो पूछ लो.
मतलब ना मुझे वो समझ में नहीं आ रहा था सब स्पेस का, वो आपने जो बीच में बोला था ना कि 1 स्पेस और 2 स्पेस, वो भी क्लियर हो गया कि पॉसिबल.
देखो बेसिकली देखो, दिखाई तुम्हें ये थोड़ी देगा, दिखाई तुम्हें ये देगा सिर्फ, है ना. व्हाट इज आइगन वैल्यू? आइगन वैल्यू इज द फिजिकल मेजरेबल थिंग. ठीक है, वो तुम्हें दिखाई देगा. तो तुम्हें अगर एक ही आइगन वैल्यू मिल रहा है तो तुम्हें सपने में आएगा कि उसके साथ 2 आइगन वेक्टर एसोसिएटेड है. इसीलिए एसजेड लेकर के आए. दिस इज ड्यू टू मैथमेटिकल कंपल्सन. आर यू गेटिंग माय पॉइंट?
यस.
चलो, so I think I will stop here, okay, because time fly कर रहा है. So because we have to go into next level of this particular thing, but I am just giving you one homework. Will you do this thing? आप करोगे या नहीं करोगे?
Yes sir.
सिर्फ किशोर करेगा, बाकी नहीं करेंगे? चलो, आपका होमवर्क बड़ा ही सिंपल है. वो मुझे कल की क्लास को बहुत ही इंटरेस्टिंग बनाने में हेल्प करेगा, क्योंकि मैं वहां कैलकुलेशन के जगह पर मेनली कॉन्सेप्ट के ऊपर फोकस करूंगा. एंड फॉर्चुनेटली आज मैंने एक प्रॉब्लम भी सॉल्व किया है फ्रॉम द बुक आर शंकर. उसे मैं बहुत ही अच्छी तरह से डिस्कस करने की कोशिश करूंगा कल की क्लास में. सो उसके लिए आपसे एक रिक्वेस्ट है कि आप Sx के आइगन वैल्यू और आइगन वेक्टर निकाल कर रखोगे. निकल जाएगा, है ना?
Yes sir.
बहुत सिंपल सा होमवर्क है, बट प्लीज करके रखना, ठीक है?
सर Sx का.
Sx का, ठीक है?
Okay.
So you have to just calculate the eigenvalue and eigenvector of Sx. 0, 1, 1, 0. eigenvalue क्या हो जाएगा? h cut by 2 minus h cut by 2. देखो सेम eigenvalue आ रहा है जो sz का आ रहा है, लेकिन eigenvector इसका क्या आ जाएगा? मैं यहां लिख दे रहा हूं, आप कैलकुलेट करके रखोगे. 1, 1 and 1 by root 2, 1, 0, 1. यही होगा ना? आप कैलकुलेट करके, सॉरी 1 minus 1.
-1 आएगा सर.
हाँ, -1. आप इसे कैलकुलेट करके रखोगे, ठीक है? ओके, एंड वी विल टेल इट 5 प्लस and we will tell it pi minus, and we will solve one of the interesting question, one of the best question ever solved in your life. Okay, बहुत इंटरेस्टिंग क्वेश्चन कल सॉल्व करेंगे, ठीक है? सो आज के लिए इतना ही रहने दो. प्लीज रिवाइज इट. Sx Sy का भी सॉल्व कर लो, आइगन वैल्यू आइगन वेक्टर, क्योंकि एग्जाम में काम आएगा आपका, ठीक है? सो कल की क्लास थोड़ी सी ज्यादा इंटेंस होगी और हम बात करेंगे क्या हो रहा है एक्चुअली, व्हाट इज दैट हैपनिंग. आप सोच सकते हो, अभी तक आपने जो वेक्टर देखा है, लुक एट हियर, दिस इज वेरी इंटरेस्टिंग. सपोज आपने जो वेक्टर देखा है, सपोज आर वेक्टर है, ये आप देते हो ए आई कैप, बी जे कैप, सी के कैप. सपोज आपने कोई पॉइंट ए बी सी लिया है, तो व्हाट इज ए बी सी? जस्ट अ नंबर.
यस सर.
एक्स लाइन पे जो नंबर मिल रहा है वही तो है. या फिर आप एक्स वाई जेड भी लिख देते हो, डोंट वरी. एक्स लिख देते हो, वाई लिख देते हो, जेड लिख देते हो. सो जस्ट एक्स एक्सिस पे जितने पॉसिबल नंबर है वही तो है, इजंट इट?
यस सर.
ये आर है तो एक्स एक्सिस पर तो पॉसिबल नंबर है वही है ना. कुछ यहां पर ये जेड का हो गया, इसी तरह से प्रोजेक्शन होगा एक्स वाई जेड. दिस इज जस्ट अ नंबर. नाउ एब्स्ट्रैक्टनेस की हाइट देखो यहां पर, वो क्या हो रहा है। और हो सकता है आज आप अगर सिंसियर फिजिक्स के स्टूडेंट हो, जो सिर्फ नेट के लिए तैयारी नहीं कर रहे हो, कुछ फिजिक्स में करने के लिए तैयारी कर रहे हो, तो आज शायद आपको नींद भी ना आए। So if I am writing S operator and this Sxi, this Syj, this Szk, and please mind it, this Sx is 2 cross 2 matrix. My goodness. और अगर आप इसी को एंगुलर मोमेंटम में देख रहे हो, तो आप यहां इन्फिनाइट क्रॉस इन्फिनाइट मैट्रिक्स देख रहे हो, isn't it? अगर मैं सिर्फ L इज इक्वल टू 2 की बात करता हूं, सपोज L इज इक्वल टू 2 की बात कर रहा हूं, तो ये कितने क्रॉस कितने का मैट्रिक्स होगा?
सर 3 क्रॉस 3 का।
L इज इक्वल टू 2 की बात कर रहा हूं, 2L प्लस 1,
5
5 क्रॉस
Yes, sir.
5 की
Five-
मैट्रिक्स
five-
होगी ये।
यस सर।
व्हाट इज दैट?
सर आई कैप डायरेक्शन में और एक्स्ट्रा 5 डायरेक्शन है।
Exactly. Very good, Kishore. Very good. Very good. Very good. And that is abstract.
यस सर।
And they are actually abstract. और वो 5 डायरेक्शन आप कैसे दिखाते हो? वेरी गुड, वेरी गुड, गुड, वेरी गुड किशोर। वो 5 डायरेक्शन आप कैसे दिखाते हो?
सर थ्रू दिस मैट्रिक्स सर।
थ्रू दिस
And-
मैट्रिक्स। लेकिन वो डायरेक्शन कौन
Yes.
सा है? अगर मैं SZ के लिए बात करता हूं तो इसके लिए वो जो 5 डायरेक्शन है, SZ के लिए कौन सा है?
MS के डिफरेंट वैल्यूज।
SZ के लिए वो जो डायरेक्शन है, वो कौन सा डायरेक्शन है? L और M के पॉसिबल कॉम्बिनेशन 2 2 एक डायरेक्शन, 2 - 2 दूसरा डायरेक्शन, 2 1 तीसरा डायरेक्शन, 2 -1 चौथा डायरेक्शन, 2 0 पांचवा डायरेक्शन। ये तो SZ के लिए है।
यस सर।
SX और SY के लिए क्या है वो डायरेक्शन? So you are writing each and everything into this basis, isn't it? आप ये जो रिप्रेजेंट कर रहे हो, किसके बेसिस में रिप्रेजेंट कर रहे हो? इन्हीं के बेसिस में रिप्रेजेंट कर रहे हो। सो along x axis,
LM, this is for LZ ना?
this is for LZ, yes, sorry, this is for LZ, yes, this is for LZ। मैं ऑर्बिटल एंगुलर मोमेंटम से आपको कंपेयर कर रहा हूं, isn't it?
Yes sir.
So z कैप के along आपको L is equal to 2 का मतलब है 5 possible directions मिल रहा है। Can you imagine the abstractness, the height of abstractness? This is actually quantum mechanics. Yes?
यस सर।
ओके कल हम लोग इसको और रिवील करेंगे, क्या हो रहा है, कैसे हो रहा है, बहुत ही नेक्स्ट लेवल पर लेके जाएंगे चीजों को, ठीक है?
सर
अब क्या हो गया?
हम 5 जो बोल रहे हैं वो इस लॉजिक से बोल रहे हैं क्या कि जब हमें L = 1 था तब 2 क्रॉस 2 मैट्रिक्स मिल रहा है।
L = 1 के लिए 2 क्रॉस 2 मैट्रिक्स कहाँ मिल रहा है मैम? मैम आप पढ़ती नहीं है ना, सिर्फ क्लास में आती हैं। L = 1 के लिए 2 क्रॉस 2 मैट्रिक्स कहां से मिलेगा? L = 1 के लिए 3 क्रॉस 3 मैट्रिक्स मिलेगा ना?
हाँ 2L + 1।
अरे तुम नोट्स पलटती भी हो कि नहीं कंचन?
सर पलटती हूँ।
पलट करके फिर क्या करती हो? देख करके सो जाती हो? हाँ?
नहीं सर। नहीं
एक
सर।
एक एक वीडियो आया था एक बच्ची का, है ना, वो नोट्स देख करके ऐसे ऐसे करके पूरा ऐसे ऐसे करके दिमाग में लेके आ रही, तो उसे खुद करने की कोशिश करो, ठीक है? सिर्फ देखने से काम नहीं करेगा, चलेगा, करना पड़ेगा, ठीक है?
हाँ। यस सर।
खुद से करती हो, कॉपी पेन चलाती हो, या सिर्फ वीडियो देखती हो?
नहीं सर पढ़ती हूँ।
नहीं पढ़ना नहीं, लिखती हो कि नहीं, मैं वो पूछ रहा हूँ।
लिखती हूँ।
कितने पेज लिखती हो एक दिन में?
सर जितना टाइम मिलता है उतना।
नहीं, थोड़ा टाइम निकालो, ठीक है?
हाँ सर।
देखो मेरा ये कभी भी ये नहीं रहता है कि मैं आपको डिस्करेज करूं क्वेश्चन पूछने से, लेकिन जब मैंने वो पहले क्लास में बता दिया है तो मैं चाहूंगा कि आप क्वेश्चन का लेवल रेज करो। आर गेटिंग माई पॉइंट?
यस सर।
है ना, जैसे 2l+1 की चीजें तो अब आपके डीएनए में हो जाना चाहिए कि नेक्स्ट जनरेशन को भी वो पता है। आर यू गेटिंग दिस थिंग?
यस।
है ना, अब तो आपके लिए 2l+1 की चीजें तो ऐसा हो जाना चाहिए कि आप अगर आईसीयू में भी हो तो भी आप उसका आंसर दे दो। ठीक है, सो ये तभी हो जाएगा जब आप प्रैक्टिस करोगे। डू मोर एंड मोर प्रैक्टिस। ओके, वेरी गुड किशोर, कीप इट अप। ठीक है,
Thank you, sir.